Here we are in the New Zealand Marine Studies Centre teaching lab at Portobello, part of the University of Otago, and we have Zoe, Jess and Elle, who are our faces for physical oceanography.
Hello, I'm Zoe. I'm a master's student at the University of Otago, and in some of the later videos I'll talk to you about tides and a hanapron.
Oh.
Hi, I'm Jess. I'm a PhD student in marine science and microbiology at the University of Otago, and I'm going to be talking about ocean structure and some of the other instruments that we use.
Hi, I'm Elle. I'm a master's student here in marine science at Otago, and I'll be helping Jess out with talking about the ocean structure, and I'll talk to you a bit later on about Van Dorn bottles.
Now we're going to have a wee look at ocean structure. So the way that we distinguish different water masses in the ocean are by two parameters. That's the salinity and the temperature. Now we're going to set up a wee little experiment here with some water that are at different salinities. So we've got our normal seawater, which is 35 parts per thousand, and we've got some saltier water at 45 parts per thousand. We might see this water in an enclosed area in the ocean where there's lots of evaporation occurring, and then we've got 25 parts per thousand, which is something we might see where there's been a lot of rainfall in a certain area. And then we've just got some fresh water here at 0 parts per thousand. So in order to make up these different salinity water, for the 25, you want to weigh out 25 grams of salt per litre, so we've got 2 litres here, so 50 grams of salt in 2 litres. For the 35, that's 70 grams of salt in 2 litres, and the 45 will be 90 grams of salt in 2 litres. Now, we're going to do it in this wee tank here, but if you're just at home, you could use a container like this. See what you've got, just something tall and clear that you can find. Okay, so I've got my 4 buckets of water, and I'm going to add in a few drops of food colouring into each, and that's going to help us distinguish which water is which when we mix it in the tank. So blue is going to be 0.
Yeah.
For 25 we've got green.
Mm-hmm.
For 35 we've got yellow.
Mm-hmm.
And 45 red. Alright, so we're going to give them a good mix. And then we can start layering our water column. Alright, so we're going to start with the 0 and just pour that directly into our container.
And at home you can just sort of do roughly a quarter, just less than a quarter with your 0. Okay. So Jess, you start with the lower salinities first and then...
Yep, start with the lowest.
And reason for this?
So what happens when we add salt into water, it makes that water more dense. So we're starting off with the less dense layer, our 0 parts per thousand, and then as we add in the other solutions, you'll see them sink below this top layer because they are more dense. Alright, so at this point it can be really handy to have someone to help you. So we've got a wee funnel here, and we're holding it right at the bottom of our tank, and then I'm just going to slowly add in the 25 parts per thousand layer.
So really slowly.
Next up we've got the 35 parts per thousand. Last one, the 45 parts per thousand. So you can see each of those different buckets of water with their different salinities have stratified or created layers inside our containers. Because the saltier ones are more dense, even though they're the same temperature, they stratify by salinity.
So when we're sampling or exploring the physical ocean, how do we learn about this? How do we find out about it?
So what we can do, one of the instruments that we have is the CTD. We deploy that off the side of our boat and we can drop it down through these layers of the ocean and measure their salinity and their temperature and at what depth they are. So that gives us an idea of the profile of that water column and what different water masses are coming from where. So the other thing that can affect stratification or layering in the ocean is temperature. So cold water is also denser than warmer water. So what we would expect if we had some really icy cold water from a cold current that's circling around the poles, Antarctica or the Arctic, that water would stay down at the bottom of the sea floor. So let's give this a go.
So when that ice forms, the ice is fresh water,
Yes.
and the seawater left behind is, because the fresh water's taken out, it's more salty.
It's more salty, yes.
So it's not only really super cold, but it's also salty.
Super saline and cold,
So
so that immediately sinks down right to the bottom of the
really
sea floor.
dense. And we're going to try and mimic this.
We're
see
going to
what
try and
happens.
mimic that, yeah.
Okay, right. So you can do this at home, a bit of freezing cold water. And gently we're pouring some in, and it's cold, and if it is denser, well, we'd expect it to sink, and it has sunk. It hasn't gone, even though we put it on the top. We put that on the top. Even though we put it on the top.
So this is we're getting some icebergs forming at the top, and it's pushing out that really cold, salty water, and then that's sinking right down to the bottom.
It's moving, isn't it, too? Like as it sinks, it moves out.
Yeah, so it's because it's denser than the rest, all the other water, it's going to push aside the water in the tank and travel and fill out the bottom of the...
Right. And so, in a way, any changes in density, like with temperature or salinity, are going to lead to movement of the water masses as well.
Yeah, for sure. And that's how the big currents in our ocean, how they're formed from different water masses.
Right.